All right, so now we got some inverse functions along with their along with another one. So we're basically doing composite functions. If you remember, we put a function in a function. But now what we got here is we've got sine, and the inverse of sine would be the angle in which we are looking for. Okay. So when you put an angle into a trig function, you should get usually a radical, okay? You're not going to get a pi answer because the tangent of something you put in a pi and get out a radical. So honestly, we could cross out C and D because that's a very unlikely output. Now let's look at this one, okay? When we look to this group, what should be happening is that when we put in a radian, an angle, okay, we're going to get a radical, but in this case it'll be like 1 or -1 or 0. And then if we took that 0 and then plugged it into the function, into an inverse function, we should get the angle, okay? And these all are angles. These are all radians, okay? If it would have had a radical, then that is not going to be the case. For example, this right here, these two radicals coming out of an arctan or an inverse tangent, that's not going to make any sense, okay? Or it probably wouldn't happen. Okay, so going back to this, this will pan out in just a second. So if you remember that sine, because remember I'm undoing sine here, I know that it's O over H, okay? And so what this means then is I need to set up a trig ratio that says that 19 is the hypotenuse and 4 is the opposite. And I always choose this lower left. I always choose that as kind of like the angle of interest, okay? Now what I want to do though is because I need tangent, tangent is O over A. So you'll notice that I need the O, which I already have, it's 4, but I also need an A. And the A is what I don't have. And so I'm going to have to pull it from this formation right here. All right? So having a ratio like this is actually really nice because you just set it up as a right triangle. So let's go ahead and grab the A. Let's find out what this guy is. Now, this is the Pythagorean theorem in action. And because this is the hypotenuse, I would go 19 squared minus 4 squared equals 345. Okay. Now, 345, if I want to know what A is, I would have to take the square root. Okay. So, excuse me. Let me just show you what that would look like. Let me show you the calculator. All right, so that's 345. Then, if I want A, okay, A, capital A equals radical 345, because I have to take the square root, okay? All right, now I see two radical 345s, but which one is it? So we need tangent now, because what we've done is we already know that this angle is going to be the same angle that goes into here, so therefore the tangent equals the O, which is 4, okay, tangent of theta equals this, 4 over square root of 345. All right, so with these two options, you can see that what they did is they multiply both the top and the bottom by radical 345 to get rid of the radical, and you'll see that nothing cancels out, so the answer has to be B. Okay, so just use this formation, and remember that if you've got an inverse on the inside, okay, you just want to use that formation to get the rest of the legs to get you that new one. Okay. But you need an inverse inside a normal function, okay? Inverse inside a normal function. Here we have the normal inside an inverse. So this is going to, these two are going to be a little different. Okay, so continue this process now with cosine. Inverse on the inside means that I basically just have to figure out the O, the H, and the A. Okay, so this guy being cosine is A over H. And what I need is for cosecant, cosecant is sine reciprocated, So that would be h over o. Okay, now I got the h, it's 4. I just need to figure out the o. So in order to figure out the o, I'm going to have to just quickly draw a right triangle and label the things that I know and label the things I don't know. Now I could put an o there, but I'm a little worried about maybe thinking that's 0. Okay, so what I'll do is I'll put an o and I'll just put a line through it to show that it's just o. Okay, not theta, but just o. All right, actually you could have put a diagonal through there like that. It doesn't matter. We're going to do 4 squared minus radical 7 squared equals o squared. Okay, and that would be 16 minus 7. That equals o squared. Now that's 9. So it looks like o has to be 3. Okay, so that means we know that the o has to be 3, and we knew that the h had to be 4. So it's 4 over 3. Okay? All right. Next, for 5 and 6, again, we have a normal function inside the inverse, so we should see an angle coming out, not a radical. So let's just be careful. Now, cosine of pi is your unit circle all the way here. So that would be -1. Okay, so I want to know what is the inverse tangent or arctangent of -1. Okay. Now, the inverse tangent, here the domain is actually really important because to be a function, tangent, like sine, means that my output has to come from these two quadrants. Okay, cosine you can have come out of here. Okay, but we can't use that third quadrant because it would no longer be a function. Okay, and so we can only use 2 quadrants for this. So what we've got to do is we've got to figure out what quadrant, okay, is tangent -1 when I put the sine over the cosine. If you remember, tangent equals 1 when both the sine and the cosine are the same values. But it also has to be negative. So here, they would both be positive at pi over 4. But over here, okay, then we would have to have it be a negative pi over 4 because I need that to be a -1. Okay, this guy is a -1. So that is negative pi over 4 because we are going in the negative direction, but I can't say that it's this negative pi over 4. He's got to be in these 2 quadrants, quadrant 1 and quadrant 4. Okay. All right, same thing with this. We've got sine of pi over 2. Okay, pi over 2 is 90 degrees, and what is the sine? Correct, it's 1. So now I'm looking for the arctangent of +1. So remember, arctangent is asking, okay, I'm going backwards through my unit circle. What input is going to give me the radian? Okay, not the radian giving me the output. Okay, so where is it 1? Well, I actually just said it over here. The positive 1 is right there where the sine and the cosine are the same exact value, because you put those over each other, it actually equals 1. So it looks like right there, it would be right there at pi over 4, so our answer is pi over 4. These guys don't make any sense because I should have it in terms of radians, because I'm looking for what radian. It's an arctangent that is the function. Okay, and this guy is highly unlikely because he doesn't have a pi, but you know, watch out for that. Okay. Okay, where are we at? 9 minutes. We will stop there.